All right, hey, thanks for joining me. Today I'm going to talk a little bit about the AI security landscape. It's very fast moving. Try to categorize it into a couple of different areas and give examples of companies. It is almost certain that I've missed companies and maybe even entire categories. And please let us know what we could add and what we could do better. So first and foremost, over half of AI projects fail due to privacy and security concerns, according to Gartner. That's an incredible amount, but it's kind of understandable because people are worried about those AI systems because they're privacy nightmares. I mean, they're just all kinds of sensitive data flowing through them, very little in the way of controls, protections, etc. But there are a lot of companies that understand this and that are trying to fill the gaps, and that's what I'll talk about today. First, let's talk about what a model is. Basically, a model, an AI model, is like the knowledge base and the decision center of the system, and they have to be built up. Historically, everyone built their own models by building up their own training sets and making all their own choices. But of course, these days, many of the models are being created by large companies, Facebook and Google and OpenAI and so forth. Whether we're talking about shared models that are like a public utility in nature or custom models, sort of doesn't matter for this point. The first class of AI security solutions we'll talk about are what I'll call the AI training data privacy solutions. Okay, this is the stuff that looks very specifically at how models are trained, the data that goes into that, and how to protect it to preserve the privacy of people whose data might be in it, or to keep it from being stolen or otherwise accessed, and so on and so forth. Basically, there's a few approaches here. Actually, it's probably the category with the most approaches. There's straight up encryption. Just secure the data, lock it up, make it so that if someone gets into your infrastructure, they can't see it. Other approaches are PII, that is to say personally identifiable information redaction, or redaction of kind of anything else. If you don't want it to be in the model where it could be potentially extracted, then you need to scrub it out of the training set. Anonymization is a similar idea. Differential privacy is sort of a similar idea. A lot of actual data comes in, but there's little bits of fudging of different bits of the data such that on the whole, it all adds up to the same stuff, but on the specifics, it's hard to tell what's whose. And then synthetic data, where you have potentially a whole different model generating data that looks like real data to train a different model. There's a lot of companies that do different parts of this. Some of the ones I was able to find searching around, mostly AI, synthesis AI. For the encryption part, Thales and IronCore Labs, my company. For other parts, assembly AI, private AI, Protopia AI, and DynamoFL. Let us know if you know of others. All right, let's shift our focus from the training data to the AI model itself, because there's a whole bunch of solutions that are focused on the model once built and/or the process of building the model and so forth. A lot of this is around sort of quality aspects, which isn't necessarily security, but a lot of those quality aspects come back to governance, testing, etc. This also, I'm including in this category things that are looking at the code behind these systems. So we could be talking about things that are looking for the use of vulnerable libraries, the use of PII in the code or in the model, or looking in the model to see if it has any PII in it instead of looking at the training data. All the governance stuff that generates reports about how the model was built, certifying sort of what went into it, and showing that it maybe does its job appropriately. That's a whole suite of stuff, and because it goes into governance and compliance a lot, we'll call it a security category. So examples here, code analysis, quality tests, attack simulations against the model to see how it behaves, that PII discovery and compliance reporting. Some of the companies we've seen here: Robust Intelligence, Protect AI, Cranium, Adversa, AdvAI, MindGuard AI. There's probably a lot more. Okay, this is all sort of on the building side, the application side, the development side. Alternately, we can look at the runtime side. Models are built to be used, and a lot of what's happening, especially today with these giant shared models, is all happening on the runtime side. And you can think of this as you have prompts or text or documents or images or audio or video or whatever, these multimodal data that goes into the model, and some kind of inferences that come out of the model. In the first set, probably the biggest category of that we saw in searching around comes in sort of in between data going into the model and data coming out of the model. We'll generally bucket this stuff as threat monitoring. Some of these companies are branding themselves as AI firewalls. Regardless, they're watching the data that's flowing in, they're watching the data that's flowing out, and they're looking for problems that indicate certain types of attacks or data leakage. So the approaches here are basically prompt scanning, anomaly detection, especially looking at results, leak detection, looking for any sensitive data flowing out, and things in that vein. Sample companies in this space: Calypso AI, Robust Intelligence, again, Hidden Layer, AI Shield, and Rebuff AI are a few we found. Then let's look at model privacy. So this is about, one, protecting the model itself. This is for maybe secret models, if you're OpenAI or someone and you don't want to just give out your model. But it's not just about that, it's also about privacy of the prompts, the documents, the images, the audio, whatever the inputs are, and the privacy of the outputs. So if someone is hosting a model, again, OpenAI is a great example. If OpenAI is hosting the model, this is ways that they could kind of keep themselves free of knowing, of being a leak of privacy risk to a company that wants to use their model. So that means that someone who wants to protect their data but still take advantage of the incredible abilities that OpenAI has, they would be looking for model privacy. And one way to do this is just to run your own model, maybe on a secure machine that you trust. But in this case, we're largely talking about something that's hosted or run on other people's servers, whatever that might mean. There's two main approaches that we've seen to this. One is fully homomorphic encryption, and the other is confidential computing. If you don't know what those are, because they're kind of jargony, fully homomorphic encryption is a way of encrypting something such that you can operate on the encrypted data, and so you can use encrypted queries, encrypted inputs, operate over it to get out. And then eventually you can decrypt the results, and that gives you your final result. IBM and Enveil are two companies that are building AI solutions in this space using fully homomorphic encryption. The other approach is this confidential computing approach, where you have some kind of trusted execution environment backed by hardware like SGX from Intel or what have you. And the data is encrypted going into this thing. It can't really be extracted if the application running inside it doesn't allow that. And it can encrypt the data before it comes back out of this thing, so someone can host the servers and not really learn anything about the inputs or what's being processed, and the people using it don't learn anything about the model. So those are the neat things. Folks working on stuff like that are Fortanix. Microsoft Azure is using the NVIDIA H100 GPUs, which provide confidential computing in GPUs, which is pretty cool, and that's a hosted space that you can use, and a company called Opaque Systems. Okay, thinking a little bit more about the runtime of models, it can get more interesting, especially these days as people wrestle with dealing with hallucinations, figure out ways to provide context, to narrow down sort of the sources that an AI, like a chatbot, might use in order to provide responses and so on and so forth. And that's what I'll call the AI memory side of the equation, but more technically is referred to as vector embeddings. And these vector embeddings, they're stored in these things called vector databases. Actually, they don't have to be, because they can be stored just as arrays in memory or as indices on disk or in a bunch of different ways. But vector databases are kind of like the hot new way to do this, and they have a lot of benefits. So then the question becomes, okay, if what's going into this memory? Because this is the model's impression of whatever the inputs are. And if it's a text and it's going through a large language model, the AI memory can basically be used to reproduce the entire text, but in new words. Same exact, sentence for sentence, theme for theme, but different words, right? It's not recording the actual original, it's recording the large language model's impression of it. And it's the same for images and other things as well. So if you're going to store this memory, these vector embeddings on someone else's computer or someone else's service, you might think about how you protect the privacy of that data. The only approach I'm aware of here is a property preserving encryption approach using data in use encryption, where you can query over the encrypted data. And my company, IronCore Labs, is the only company I know of that has a solution in this space today. That may change, or that we may not be aware of something, but we have looked and we haven't found any other solution here. This is a pretty good solution for this piece of the puzzle. So altogether, we're looking at 5 different categories: the memory privacy, the model privacy, the AI training data privacy, the model and code testing and auditing, and the threat monitoring kind of AI firewall that sits between a potentially malicious user and your models. And that's the landscape for secure AI. Please leave us feedback. Let us know what we missed, or what categories we're doing, or if we've oversimplified a category in some way that should be split out. But hopefully this is helpful for anyone who's trying to understand this space and trying to understand how they might deal with the security and privacy concerns of these new AI systems as they build them out. Thanks for listening.